Alright, welcome back to the Lesson 8 quiz. And when we left off, we were trying to figure out where the resultant is, where this is equal distant, if that makes any sense. And I tried to explain it by trying to say, okay, just pretend it's a teeter-totter. And at what point does this fulcrum, at what distance is the fulcrum? That needs to be the center line of your footing. So anyways, let's continue. It's easier, once again, it's easier to just do the math and have you look at the math and see what exactly I was trying to explain here. So let us continue. Alright, so we know that this is what, 20 foot. So this entire distance is 20 foot. We're going to call one of these distances x. Let's name the longer distance x. Then the shorter distance would be 20 minus x. Let's put it in parentheses so you can think of it as one single entity. This distance is 20 minus x. And that's because the entire distance is 20 foot. Alright. So we know that 24.5. Let's go ahead and drop the units. X is going to be in foot. We know. So let's drop the units. 24 point, and then 120 minus x is your distance equals 200 times x. Let's go ahead and multiply that out and then solve. Let me get my calculator here. 24.5 times 20, because I don't want to do that in my head, is 490. So you have 490 minus 24.5x equals 200x. Let's go ahead and add that to the other side. And we're going to get, because remember it's plus 24.5x, so you're going to have 224.5x equals 490. Divide each side by 490, and let's go ahead and put it up here. X equals what? 490 divided by 224.5. You get 2.18 foot. 2.18 foot. Alright, so that's not really an equal or a simple distance. Let's go ahead and figure out what that distance can be. Actually, I must have messed up on my math here, because if you look at it, this doesn't make too much sense. So if x does equal 2.18, then that's going to equal 18. Yeah, that ain't right. X needs to be should be slightly over 20. So somewhere I messed up on my math. And that's one of those dummy checks. I am a dummy. Just doing a great big check here. So let's try to figure out what I did incorrectly. Let's start over. So you're going to have that force, 4.5 times 20 minus x distance. Yuck, that's gross. 20 minus x, there we go. Equals this times x, 200 times x. And I'm probably going to come up with the same thing, so I see what I did wrong. And this is pretty dumb. It's actually 245, not 24.5. I just read my own writing incorrectly. 245, and I apologize for that. So 245 times 20 equals, there was our issue. So we were probably off, what, a factor of 10? So 4,900 minus 240, oh no, we're off more than that. Anyways, we're just going to do the math and see what we're off. 245x equals 200x equals 445x, 4900, x equals 4900 divided by 445. And this should make more sense. Alright, and we're at 11.01 foot. So let's just say 11 foot, because when you double it, it should be 22 foot. Or never mind. we're not going to double it. 11 foot from here, from point A. So this is going to be 11 foot plus 3 is 14 foot. So let's go ahead and change colors here. Let's do a bright color. The distance to your center line is going to be 11 foot. No, 11 foot, so it's going to be 14 foot. 11 foot to A, it's going to be 11 foot. And up here, let's erase real quick. I'm taking a lot of time on this one problem, but that's all right. So that's 11 foot here, and it's going to be 14 foot. And therefore you're going to have a 14 foot over here because that's the center line. And therefore your footing is going to be 28 foot. So let's go ahead and put that up here. 28 foot times what? So now we need to take the complete load and look at the bearing pressure. So we need to take the complete load, which is going to be, here's total load. We'll call it TL, just for short. TL equals 245. That's B plus 200 kips plus, what was our footing weight? It should have told us. It did. 40 kips. So our total load equals what? 445, 485. All right. So now we want to go over to the bearing pressure. You know, the F equals P over A. Let's just do P over A. Let's do B, bearing pressure equals P over A. And we know that our allowable is going to give our A min. Our max allowable is going to give our A min. So we want to say 4K SF equals P, which we know, 45 kips. And we're figuring out 28 foot times the width. So we'll say W. And remember, sorry about the drawing, but this is going to be W. Distance W is our width. We already figured out our length, and area equals length times width. So W equals, we put it over on this side. So we need to say W equals 485 divided by 28, and then divided by 4. It's 4.33. And actually, that looks like it will work out pretty well. Equals 4 foot 4 inches. And it's up to you if you want to round up to 4 foot 6 or whatever. But 4 foot 4 is an acceptable thing. I would never do anything to a ½ inch or a ¼ inch in an 1/8 inch in concrete. Usually, what we always do is we go to an 1/8 inch in concrete is acceptable, and a 1/16 inch in steel is acceptable. But in a footing, I would not go to anything under an inch, and even an inch, maybe a ½ foot is something, or maybe every 3 inches is something that you want to do. So it kind of looks at what designer is, and we'll leave it to you what you want to do. All right, so there it is. It's 28 foot times 4 foot. Oh shoot, 4 foot 4 inches. Let's see if that's an answer. And it is 28 times 4 foot 4, and that is answer A. And I agree with that. So there we go. Let's go ahead and erase and move on to answer 7 or 8. And I know that took a while, so hopefully these word problems I'm okay with them being shorter, but these design problems like that need a little bit more to it, and that's all right. Let's go to pink. Let's switch it up. All right, 8. The calculations for a square column footing shown that the footing is overstressed and shear. Okay, what is the best way to correct this situation? And I'm going to, just before I look at any answers, I'm going to say increase the thickness of the thing. So let's say it's it's short. So your moments, your moments is going to be force time distance. Since this is a short, it's a foot. Let's say you're not going to have too big of moments there. But let's say you have a pretty darn big P load, so you're going to have shear. Your shear is going to be pretty big. So typically you won't have shear reinforcing, and I think it says this, and I'm pretty sure it does in the study guides as well. But you'll want to, you can have shear reinforcing. That's a possibility. I'm not going to throw it and say it's impossible. But typically what you'll do is you'll just make it a little bit thicker, and that concrete, that extra concrete will resist that shear force. All right, so let's see what our possible answers are. Provide shear reinforcing. Remember, it says the best way. That is an option. I agree with that. Not the best. Increase the thickness of the footing. I agree with that. I'm going to go ahead and say B. Let's see what the other answers are real quick, though. So 8 is B. C, provide additional no, that's not going to help. And D, decrease the column load. Okay, yeah, if you can do that. But typically, just increase the footing. Yeah, if decreasing the column load is an option, that's probably going to, that's probably going to mean you're going to have to increase the number of footings, number of columns, and that's going to be expensive. So that you could even say that that's the incorrect answer as well. All right, number 9. What should be dimension D of the square footing shown above? And then it says the soil weight is 100 pounds per cubic foot, concrete weight is 150 pounds per cubic foot, and the soil bearing value is 5,000 pounds per square foot. All right, so let's figure out what our load is, and then we'll figure out what our bearing capacity and figure out what area we need. So we have what, 200 kips dead load plus 150 kips live load plus, well, plus 100 pounds per cubic foot times 1 foot, which is 100 pounds per square foot, and then 150 pounds per cubic foot times 2 foot, which is 300 pounds per square foot. So that's going to be what? 400 pounds per square foot times whatever area we have, times, side D squared, I guess. That's the area since it's a square. All right, so what this is going to be, we can figure this out later, but if you say it's going to be 100 square foot, let's say it's a 10 by 10, then times 400, that's going to be 40,000 pounds. So that's getting up there. It's going to be 40K, let's say. Let's assume this is going to be 40K, just for simplicity. We'll come back, say 40K, and that's assuming 10 by 10, 10 foot times 10 foot. If you look at the answers, actually, none of them are that large. So we're being a little conservative, and that's all right. Then we can go in and kind of make it a two-step process where we get the D that we think it is and redo it and see what we get. All right, so 40, 250 plus, that's what? 390. Well, let's work with that. And our allowable was 5 KSF equals P equals 390 kips over A, which is going to be D squared. All right, so D squared is going to equal 390 divided by 5. 78. The square root of 78 equals 8.83. And let's round up to 8'9". Yeah, there we go. That's good enough. 8'9", or is around there. Let's pick 8'9". Go back in here, and I'm not going to do this because I'm running low on time. But put 8'9" in here and see what you get. It's going to be less. It's actually going to be less. So we know that this is too conservative. But we did get close to 8'9". 8.75 is close enough to 8.783. So 9 is going to be A, and then 10, I'm going to try to sneak this in real quick. Soil bearings indicate that a site has 4 to 5 feet of loose fill. Select the most correct state. And I'm not going to get into it since I'm running out of time and don't want to make another video for one short little question. The answer is C. And I suggest you go back to the beginning of the chapter and read the section on compacted fill, and you will get a good idea for why that is. Thank you, and I will see you on the examination.